Hello and welcome to my talk. My name is Marian and I'm currently a PhD student in my final year at the Max Planck Institute for Astronomy in Heidelberg, Germany. In my 5 minutes I'm going to talk about the relevance of major galaxy mergers in triggering AGNs, in particular AGNs with the highest Eddington ratios. Contrary to the long-standing belief, it appears that major mergers are actually not the dominant mechanism to trigger AGNs. For a wide variety of different AGN populations, no enhancement in merger rate was found, especially when compared to a sample of matched inactive control galaxies. Now, in our work, we investigated the role of major mergers in triggering AGNs with the highest Eddington ratios. Because due to their nature, they require a huge amount of gas in a relatively short time span, and hence major mergers may still be the most feasible option for the existence of such particular AGNs. So what we did first was to examine a sample of AGNs with a matched sample of inactive galaxies at redshift 2. Based on SDSS DR7, we selected AGNs in the black hole mass range around 10 to the 8.5 solar masses and an Eddington ratio greater than 70%. We observed 20 AGN host galaxies with HST and selected around 100 inactive galaxies from the candle survey. As a comparison, we repeat our analysis for a local sample of AGNs. This time at redshift 0.2, but still with similar black hole masses and a cutoff in Eddington rate greater than 30%. We have again around 20 AGNs and this time 25 inactive galaxies, both observed with VLT4s. At redshift 2, the resulting merger fractions are very similar, with the AGN host galaxies showing no significant enhanced merger incidence. Hence, we conclude that at cosmic noon our particular population of AGNs is not predominantly triggered by major mergers, and our result consistent with the studies I just presented in the beginning of this talk. However, at redshift 0.2 we actually find quite the contrary result. While the merger fraction for the inactive galaxies is consistent with other studies investigating the merger rate of the general galaxy population and is therefore about 10%, our AGN host galaxies have a merger rate of around 40%. This means that they show quite an enhancement in merger rate, implying that major mergers are at low redshifts an essential triggering mechanism. Still, our result also indicates that around half of our AGNs are not the result of a major merger. So while I show here the corresponding probability distributions for the merger fractions I just presented, highlighting on the one hand the similarity at redshift 2 and on the other hand the disparity at redshift 0.2, I would also like to present a possible explanation for the different results. At redshift 2, the cold gas fraction is on average still high enough to trigger AGNs via multiple means besides major mergers, including minor mergers, bar instabilities, secular evolution, environmental effects, and so on. At redshift 0.2, however, the cold gas fraction is significantly lower and major mergers become therefore an essential but still not the sole mechanism to deliver a sufficient amount of gas to the central black hole to achieve such high Eddington rates. Currently, we are repeating our analysis for simulated AGNs and control galaxies at redshift 2 provided by the cosmological simulation Illustris TNG. This not only gives us the opportunity to compare the merger fractions within the simulations, but also with our results based on our observations and also the true, i.e. simulated merger histories. This is still very much work in progress, but the preliminary results are basically identical to the results we got from our observations. So to conclude, major mergers are not the dominant trigger for AGNs, also not AGNs with the highest Eddington ratios. Still, in the local universe, we see for this particular AGN population a significant excess in merger incidence when compared to a matched control sample, something which we don't see at redshift 2. Thank you very much for your attention, and I'm looking forward to your questions.